All right, ladies and gentlemen, today we're going to take a look at section 6.2, which is applying properties of rational exponents. So you've gotten a little taste of this already as we looked at the basic properties of exponents and started applying them with rational numbers. So today we're going to elaborate that a bit further. So the first thing we want to do is take a look at two important properties of radicals, and both of these properties you already saw when we were simplifying square roots. The first of these properties is going to be to take a look at the product property. If I'm taking the nth root of the product of a times b, I can go ahead and rewrite that as the nth root of a times the nth root of b. Okay, similarly, if I'm using division, if I'm taking a quotient, if I have the nth root of a over b, I can break that down into the nth root of a over the nth root of b. So now we have to say, well, what if I'm no longer simplifying a square root? How can I take the third root or the fourth root of some number? So let's take a look at that by going through a couple practice problems. Okay, so we want to simplify the following using either the product property or the quotient property. And I'm going to start with a review of some of the stuff we talked about with taking the square roots. If I want to simplify the cubed root of 125. I'm going to go ahead and break that down by making a factor tree, just like we did with square root. So I can say 5 times 25, and I know that I can break 25 down into 5 times 5. Now, instead of looking for groups of 2, I want to look for groups of 3. I want to find any number that appears 3 times because 3 is in my index. So I know that the cube root of 125 reduces to 5. And similarly, I can break 8 into 2 and 4. And 4 I can break down into 2 and 2. So I have another group of 3. I have 3 or 2 triples. So 5 times 2 is going to give me a final answer of 10. Okay, going on to the quotient property. If I want to take the fifth root of 96 divided by the fifth root of 3, I can go ahead and rewrite this as 96 over 3. And I'm going to see that this simplifies to the fifth root of 32. Now, I still need to check and see if I can simplify 32, so I'm going to start breaking it up. I'm going to say 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. Sorry that went out of the box a little bit, but I see that I have 1, 2, 3, 4, 5 2's. So I know that I can simplify the fifth root of 32 as 2. Okay, which tells me that the fifth root of 96 divided by the fifth root of 3 gives me 2. I'm going to do the same process for this third one. So I'm looking for the cube root of 104. So I'm going to start finding a factor. I know that 2 goes into 104 52 times. I can split 52 up into 2 and 26. And finally, I can split 26 up into 2 and 13. Now, I'm still looking for groups of 3 because I'm taking the cubed root. So I see that I have one group of 2. So 2 is going to go on the outside. I don't have any more 13. So 13 is going to go back under the radical. But I have to make sure I keep my index the same, just like it was in the original problem. Okay, now for this last one. Okay, this one's going to be a little bit different. We're going to kind of reach a dead end. 7 is a prime number. There's nothing that I can pull out of 7 other than itself and 1. So for this one, I'm going to do things a little bit differently. I'm going to do some problem solving. I know I can't simplify the fifth root of 7 or the eighth root of 7, so I'm going to go ahead and rewrite it in rational form. I know that if there's a 5 in my index, there's a 5 in the denominator. So I can write both of these as 7 to the power of 1 over 5 over 7 to the power of 1 over 8. We said last week, if my bases are the same, then I subtract my exponent. So if I get out my calculator, 1/5 divided by 1/8 is going to give me an exponent of 3 over 40. And we just have to be careful. Remember that our bases do not change. I know that 7 over 7 is 1, but I have to leave it as 7. Okay, so hopefully you guys can see a relation between finding the nth roots and simplifying square roots. So I'm hoping that this first section relates back to what we've done in the past. Now, let's take a look at adding or subtracting exponents. Anytime we're doing this, we want to look for a quantity of how many terms are present when we find the sum or difference. So in these cases, we're really only performing operations on the coefficients that are in question. Now, if I look at this first example, I have 1/4 root of 10, and I'm subtracting 7/4 roots of 10. So I'm going to look at this. I can say, well, I know I'm using 1 minus 7 times the 4th root of 10, and I can simplify this. 1 minus 7 is negative 6. So my final answer is negative 6 times the 4th root of 10. Okay, similarly, I have 4 9 to the power of 2 over 3, and I have 8 times 9 to the power of 2 over 3. So these are my like terms, and I want to know how many I have in all. So 4 plus 8 times 9 to the power of 2 over 3, and I can say that I have a final answer of 12 times 9 to the power of 2 over 3. And I'm going to leave this as my final answer because technically there's an answer or an exponent of 1, and my bases are different, so I can't go any further. I'm going to leave those. Now for the next two, we see that we don't have the same number under the radical. Okay, 81 does not match 24, and 54 does not match 2. So I'm going to have to do some work, and I want to use both the quotient or the product property from up above, from the previous example. So I'm going to start simplifying my terms. I'm looking for the cubed root of 81, so I can say 3 and 27. I can break that down into 3 and 9, and of course 3 and 3. Okay, so I can rewrite the cubed root of 81 as 3 times the cubed root of 3. And I can break down 24. I have 2 and 12, 2 and 6, and then 2 and 3. So I have one group of 2's. And keep in mind that we're subtracting. So I'm going to say minus 2 times 3, radical 3. Now remember, we're only working with our coefficients. So 3 minus 2 is going to give me a final answer of 1, 3, radical 3. And that's going to be my final answer. Okay, why don't you go ahead and pause the video. I would like you to try letter D on your own. So we want to use the same thoughts, the same processes from the previous question. But why don't you go ahead, pause, and then go ahead and check your work. Okay, I went ahead, I showed most of my work for letter D. I did not write my final answer though. I know that because 2 is prime, I'm not going to be able to do anything to simplify the second term. So I'm really going to put my energy into the first one. I know that I can break 54 into 3 and 18. 18 we can break into 3 and 6. And then finally 6 we can simplify to 3 times 2. So I have one group of 3's. So I'm going to pull it in front. 2 doesn't have a pair, so it's going to go back under the radical. I know that technically there's a 1 in front of my second term, so lastly 3 minus 1 should give me a final answer of 2 times the cubed root of 2. And that's our final answer once again. Okay, go ahead, let's turn to the back of your paper, and we have a couple more examples. Okay, there's about 9 more examples on the back that get a little bit more complicated, and they do include a lot of the ideas that we were just talking about. So we're going to do things slightly different for these next couple of questions, so please pay close attention. For this first one, I see that I'm taking the 4th root, and I see that I have 4 m's. Okay, so remember, if I'm looking for groups of 4, I want to see what I can cancel out. Well, this 4 on the outside is going to cancel the 4 on the inside. So my numerator I can write as m. And then I also know that 4 is going to go into 8 twice. So I can leave my denominator as 2. So my final answer should be m over n squared. Okay, moving on to the second problem. I'm going to use the same process that we talked about in class. I'm going to rewrite this, giving myself a little bit more space. So I have 14 times x times y to the power of 1 over 3 divided by 2 times x to the power of 3 over 4. And I'm going to separate z to the power of negative 6 because it doesn't line up with y, and I'm going to give it its space of its own. I know that 14 over 2 is my first term in question. So 14 over 2 is 7. X divided by x to the power of 3 over 4. I know that my exponent is 1. So 1 minus 3/4 is 1/4. There's nothing to divide y to the power of 1 over 3 by, so that's not going to change. And then finally, if I have a negative exponent in the denominator, I actually want to go ahead and move it to the numerator, and it's going to become positive. So my final answer should be 7 times x to the power of 1 over 4 times y to the power of 1 over 3 times z to the power of 6. Okay? Now, for this third question, we're looking for the fourth root. So the first thing I want to do is I want to simplify the fourth root of 625. So I can come back and say, well, I have 5 and 125, 5 and 25, and then, of course, 5 and 5. So the fourth root of 625 is going to give me 5. So I can pull a 5 out on the outside. And then I'm also going to recognize that 4, this 4 on the index, goes into 12 3 times. And since it's even, I can go ahead and pull out z to the third power. Okay, so I'm going to use the same idea of grouping for these next couple of questions. So bear with me. If you have questions, please make a note so we can discuss them in class on Tuesday. Okay, now for this next one, I'm looking for the fifth root of 4 times a to the 8th, b to the 14th, and c to the 5th power. Now I'm going to do this very carefully. I know I'm not going to be able to simplify 4 because there's no number to multiply 4 times. So I'm going to put that back on the inside. I know that 5 is going to go into 8 once, and 8 minus 5 is 3. So I'm going to put a to the third back on the inside. 5 is going to go into 14 twice. 5 times 2 is 10. 14 minus 10 gives me b to the 4th power. And finally, 5 goes into 5 once. So I'm also going to be able to pull out a c. So my final answer should be a times b squared times c multiplied by the 5th root of 4 times a cubed times b to the 4th power. Okay, moving on quickly. I know I'm running out of time. I don't want to keep you past our 15-minute limit. 6 is going to go into 6 once, so I have x in my numerator. 6 goes into 18 3 times, so I have s cubed, and that's my final answer. Okay, over here, we should notice that 3 would go into this bottom term in the denominator if it were a 9, so I'm actually going to go ahead and turn it into a 9. I'm going to multiply it by y in the numerator and the denominator. So I'm going to rewrite this as the third root of xy over y to the 9th power. Now, 3 goes into 9 3 times. So I'm going to have y cubed, or 1 over y cubed, and I'm going to multiply that by the cubed root of xy. Okay, so that's one thing. We're going to talk a little bit more about this. So maybe put an asterisk by it and we will come back to it. These next couple should be a little bit more familiar. I'm looking to multiply, or not to multiply, I'm looking to add or subtract. So I'm looking for like terms. So I see that each term has xy to the power of 1/4. So I know I want to wind up working with my coefficients. So 3 minus 8 times xy to the power of 1 over 4. 3 minus 8 is negative 5. And my final answer should be negative 5 xy to the power of 1/4. Okay, we're getting really close, guys. You're doing an awesome job. I know over here for this second to last one, I can't simplify this too, so I'm going to focus on the second part, okay? And I'm going to have to do a little bit more work. But 54, I can go ahead and simplify as 2 and 27, which I can break down into 3 and 9, and then 3 and 3. So this second part, I can go ahead and rewrite as 3z. This 2 has to go back in, so I'm going to leave it as 2z squared. And over here, I know I can't simplify that 2, but I can pull out a z. So I'm going to have 12z, since 3 goes into 5 once, and 5 minus 3 is 2. I'm going to be left with 2z squared. So if I have, so this is for this one, this is for that one. If I have 12z times the cubed root of 2z squared minus 3z times the cubed root of 2z squared, my radicals are combined, and I should have 9z times the product of 2z squared. I'm going to go ahead and stop here, guys. We will pick up with this last example on Monday. Please make sure that you take note if you have questions and come to class prepared to discuss your answers. Have a great weekend. Bye.